Hello and welcome. Today we are going to talk about matrices. Now the plural word is matrices, the singular word is matrix. First of all, what is a matrix? Matrix is a data entry like this. And this is a 2 by 2 matrix. Now what do I mean by 2 by 2? See, there are 2 rows. That's why this number 2. And there are 2 columns. That's why this number 2. So 2 rows, 2 columns, we call it 2 by 2 matrix. And the size of the matrix is 2 by 2. Now if I write something like this, this is 2 by 3. Why? Because 1, 2 rows, 1, 2, 3 columns, right? And how about this? This is only 1 row, so 1 by 4 columns, right? 1 by 4 column, 1 by 4 matrix. And we call such a matrix a row matrix or row vector. We'll talk about vectors later. And what if you had something like this? Now in this case, 3 by 1, right? Just 1 column, so we call it a column vector. A column matrix. Now, whenever normally we denote matrices by capital letters. Now the matrix A is 2 by 2. So in general, if a matrix has n by n, that means same number of rows and same number of rows and columns. So number of rows and columns are the same. In that case, we call it a square matrix. So A here is a square matrix. Now, there are some special square matrices. Before that, any matrix having entirely zeros, we call it a zero matrix. It can be any size. It doesn't have to be a square matrix. It can be a zero matrix, can be something like this. Now let's talk a little bit more about square matrices. Now, this is a special square matrix. This is 2 by 2 matrix. And this one we call identity matrix. Now the reason why we call identity will be explained in detail when we do matrix multiplication. For the time being, just remember this is identity matrix and we have a special notation I2. Why? The size is 2 by 2. And you can guess I3 is going to be like this, 1 0 1 0 1 0 0 0 1, and I4 so on, and I1 it's just 1. So the point is, an identity matrix, you have 1 1 1 in the main diagonal. Main diagonal is the diagonal going from top left to bottom right, and everything else is 0. So that is an identity matrix. Next, we are going to talk about notation, a general notation. Say the matrix A, generally let's say it's 2 by 2. I can write down A11, A12, A21, A22. Now, let me explain this notation. Here, this first one, this 1 1 means first row, first column entry. 1 2 means first row, second column entry. 2 1 means second row, first column. 2 2 means second row, second column. So in this kind of notation, It's clear with this notation, the entry gives us the position. So let's say B is 3 by 2 matrix. So in this case, B, see, normally for the name of the matrix, we use capital letters. For the entries, we use simple letters. That's a convention. So let's say B11, B12, B, no, that's it. Why? Because we only have two columns, right? So B11, B12, then B21, B22, and B31 because we have a third column, and B32. Okay, I think that is clear. Now, if two matrices are equal, each entries are equal. So let's say A is X, Y, T, U, and B is 4, -1, 0, let's say A, and it is given that A equals B. If that is the case, then each entry, see, X must be 4. X is 4, Y is -1, T is 0, and V is A. So two matrices are equal if and only if they have the same entry. Now it's the time to do matrix addition as well as subtraction, because addition and subtraction are inverse operations, and subtraction, this is really easy. Let's say matrix A is 4, 3, 1, 0, and matrix B is -1, 5, 20, 100. So A is 2 by 2, B is 2 by 2. And remember, we can only perform addition if these sizes are the same, otherwise we cannot. So in that case, we define A plus B to be just, you just add the corresponding entry. So 4 plus -1, that means 3. Then 3 and 5, when you add them together, 8. 1 and 20, you get 21. 0 and 100, you get 100. Simple as that. Now let me do a quick example. Now, next, let me, matrix multiplication. Let me choose another color. Matrix multiplication. Let me do it here. Actually, there are two things. Scalar multiplication by a scalar, multiplying a matrix by a scalar, and a matrix multiplication, that means matrix times matrix. Now this is a little bit different story, and it's in our next video. So today we'll talk about by a scalar. This is really simple. Let's take an example and see this. Let's take this A, and if you want to multiply A by 2, 2A, okay, you put 2 in front of your matrix like this, and then simply you multiply each term by 2. So 2 into 4, 8, 2 into 3, 6, 2 into 1, 2, 0, right? Simple as that. Now let me create a quick example with these A and B. So how about if I ask you to find 5A minus 3B plus 2I2? Okay, a simple, quick, nice example. And pause the video and try it. Assuming you have tried it, how do you do? So 5 times A, you write down your A, 4310, minus 3, and then your B, -1, 5, 20, 100. And I really recommend you to write it down like this without trying to do it in your head if you are really beginners. 2, I2 is 1001, right? And then I would suggest you to, term by term, 20, 15, 5, 0. So that's scalar multiplication. And then okay, here, let me go to the third one and deal with it first. So 2, 0, 0, 2 Second one, because of the minus sign, you have to be careful. So this minus right here, this minus is this. I will leave it for the time being like that minus, and then I will take this 3 inside. So 3 into negative 1, 3, 3 into, sorry, negative 3, and 3 into 5, 15, 3 into 20, 60, and 3 into 100, 300. Now let's do the addition. So let me do it here. Now I have enough space. Here, the first entry is going to be 20 plus 20. Okay, 20. Second one minus 3. So minus 3, and last one plus 2. So this, and this, but in the second one you have to be careful. This 3 coming with a minus, so minus 3. And the next entry 5 minus 60 plus 0. And the next entry 15 minus 15 plus 0. Last entry 0 minus 300 and plus 2. So the result, let me write it over here. 20 here plus 3 and 25. 5 minus, okay, negative 55 and 0 and negative 298. See, the result still is 2 by 2 matrix. I think that is clear. So in our next video, we will start from here, and also in that video, you will have an understanding why we do all these things. So this is helpful in system of linear equations. That's one reason why we do this. Okay, thank you.